Hello everyone, I am Dr. P. Rajkumar, Assistant Professor, Department of Mechanical Engineering. Welcome to Machine Design course. The topic for today's discussion is design of parallel fillet and transfer fillet welded joints. So at the end of this session you will be able to understand how to design parallel fillet welds and the transverse fillet welded joints, and what are the types of welded joints, and what are the advantages, what are the disadvantages, what are the constraints, how to design the welded joints subjected to different loading conditions. You will be able to understand all those things at the end of this session. So let's start the session. So what do you mean by welding? Why we have to do welding? So welding is nothing but it is a joining of two materials by heating them to a suitable temperature and joining them with or without application of the pressure. So welding is nothing but by applying a pressure or without applying the pressure, and by heating the material to the suitable temperature we can join them. That joining process will call welding. So what are the advantages of this welding process? So it is tight and leak proof, and for the welding the time required is very less. The appearance also will be good, the welded joint appearance also will be good. The strength of the welded joint is very high, and it can be easily and economically modified to meet or to withstand our requirements. So these are the different advantages of the welded joints. And coming to the limitations, what are the limitations of the welded joints? The welded joints, once you join the two plates using welding operation, some stresses will be developed inside the material. So those stresses means residual stresses will be developed inside the material, and due to heating of the material there will be some thermal distortion, because of which it will lose some of the mechanical as well as the thermal properties. That is one limitation. And possibility of the cracks during welding or in the usage, both the times there is possibility of the cracks. These welded joints are not good for withstanding the vibrations, because for these vibrations they should have high strength condition, means good strength conditions. So that's why for high vibrations these welded joints we won't be preferred. And inspection of the welded joint is more specialized, and at the same time it is very costly, because we need very skilled persons to certify whether that welded joint is proper or not, whether it is leak proof or not. To certify that one we need a skilled person. So these are the different limitations of the welded joints. And now coming to the classification of the welded joints, you can see it here. Majorly the welded joints are, first one is the single transverse fillet weld. Here single transverse in the perpendicular direction, single transverse fillet weld. Here it is first one. Here it is double transverse fillet weld. Here single, here double transverse fillet weld, and third one is the double parallel fillet welds. So these two are the transverse fillet weld, and this is the parallel fillet weld. This is the configuration how we have to show for representation, and this for double transfer, this for single transverse. And T joint, edge joint and corner joints are the different types of lap joints. Here T, and you can see here the corner, the edge, entire edge is given for the joining purpose. So these are the different types of lap joints. And now coming to the butt joints, what are the types of butt joints? So as already discussed, the types of butt joints are square butt joint, V butt joint, U, double V, and V joint with some backing strip. This is the backing strip. So these are the different types of the butt joints. So now coming to the nomenclature. So here the leg size, the leg is the usual method to specify the and measure the weld size. If you want to measure the what is the weld size, then you have to measure the length of the weld. This will give you the weld size. And this throat thickness will give you the strength of the fillet welds. Will give you the strength of the welds. So these are the two different parameters. One is leg, another is the throat thickness. These two parameters you have to consider during the designing of the your parallel fillet and the transfer fillet welds. So coming to the first classification, that is design of the lap joint subjected to single transverse fillet joint. That means in this category. In this category, single transverse fillet weld. So single transverse fillet weld. Here you can see these are the two plates which are used to join. Here S is the thickness of the plates. So by connecting this leg size here, S is the leg size. So from the triangle PQR, this QS will give you the minimum area, minimum triangle area. That is RSQ will give you the minimum triangular area. QS will give you the throat thickness. QS is the throat thickness. So by substituting all the values, you will get the sin 45 value as SQ by your QR. So by substituting the sin 45 in that given equation, you will get the value of the T value, that is throat thickness value you will get. Once you will get the throat thickness value, you can calculate the area as length into thickness. So the length into thickness, here the thickness is S into sin 45, you will get 0.707 S. So by substituting this value in the equation, that is what is the equation? Your stress is equal to load per area. That load is nothing but your stress into area. So here you have now area, nothing but your thickness into L. L, whatever L values you have taken, okay, thickness into L value. This thickness value here nothing but throat thickness. You can consider that throat thickness value from this equation, that is 0.707 into S. So the load is P is equal to tensile stress, that is sigma T into throat area, T into L. So substitute this T value in this given equation, you will get the load acting on the welded joints. P is equal to 0.707 into S into L into sigma T. This for single transverse, and same thing, single transverse load per unit area, load per unit area. This for transverse, double transverse fillet. If one is 0.707, it will be into 2. So 2 into 0.707 into H into L. So that will give you the 1.414 H into L into sigma T value. So this is for single transverse equations, this for the double transverse equations. So now let's see how to design the fillet welds for the double shear stresses, that means double transverse loads. This is a double transverse load. Now this condition is for the parallel fillet welds. So here also the area will be your throat thickness into the length. So by substituting that value, you will get the area is 0.707 S into L. This is the area of the your welded joint. So we know that 2 into 2 area, okay, 2 into 0.77 into S into L into tau shear stress value. So by substituting these values, you will get the P values. If you want only small things, you can use only 1 here. So what is the P value? You can calculate here. P is equal to 1.414 into S into L into tau L. You will get the P value from in this equation subjected to only parallel fillet weld. If you see both parallel is there, transverse is there, then the load will be calculated using these equations. So these are the different special cases of the fillet welded joints. Now you see here one circular fillet weld, it is subjected to torsion. One plate is there, one circular rod is there. Both are joined using welded joints. Now we have to find out what are the maximum stress developed inside this cross section. So for that cross section, you know that in order to calculate that one, T by J is equal to tau by R is equal to G theta by L. So T by J is equal to tau by R. So from this equation you can calculate the tau max value. So by substituting all the values you will get the 2.83 times of twisting moment or torque by pi s d square. S is nothing but your leg size, S. D is nothing but your bore, D. So 0.707 S into d square. D is nothing but your diameter of the rod. So substitute all the values in these equations, you will get the tau max value. So similarly the circular fillet weld subjected to the previous one is only torsion, now only bending moment. So sigma B is equal to m by z, you will get the values. Similarly the long fillet welded subjected to the torsion, long fillet weld it is subjected to the torsion. So by substituting all the required data in the given equation, you will get the tau max value as 4.242 T twisting moment by throat, S is S into L square. So these three are considered as a special cases. Now let's consider one problem here. So what it is saying, a plate 75 mm width and 12.5 mm thick is joined with another plate by a single transverse weld and a single transverse and a double parallel fillet weld as shown in the figure. The maximum tensile and the shear stresses are 70 and 56 MPa respectively. Now they are asking you to calculate the length of each parallel fillet weld. That means here if you assume this is L1, if you assume this is L1, if you assume this is L2, then they are asking you to calculate the L1 and L2. If it is subjected to both static and your fatigue conditions. So let's see, the L2 is the length of the L2 is the length of each parallel fillet. So they are treating it is L2 is this one, L1 is your transverse. So now for the area is nothing but what is the formula? Here the load area into stress will give you the maximum load that the plane can carry, the blade can carry. So area into stress. So by substituting area value and the stress values in this equation, I will get the P value. We know that P, the total load acting on the fillet welds, P is equal to P1 plus P2. These two will give you. So P1 is nothing but the transverse fillet weld, P2 is nothing but parallel fillet weld. So substitute all the values in the given equations and give me P1 plus P2. So that P1 plus P2 value will get around 65,625 is equal to P1 plus P2. From that equation you will get the L2 value as 27.2 mm. So since it is L2, it is already taken the width. So the final L2 value will be given by 27.2 plus the width. So thickness 12.5 mm. So 27.2 plus 12.5 is equal to 39.7. We will round it to the 40 mm. So 40 mm is the length of each parallel fillet for static loading conditions. So this is how we have to calculate the design of welded joints, parallel and transverse fillet welded joints. So these are the different textbooks for your further readings. Thank you.